All right, good morning and welcome to Plenary Session 3. And in something of a contrast to the academic presentations that we saw this morning, we'll now hear from the business end of modern CCS projects. So we have three speakers with a very industrial slant. In the past, we've quite often set up a little panel afterwards, but I've noticed there's been a lot of questions from the online participants. So I'll just continue with one speaker, then questions, one speaker, then questions. But perhaps if we have a little time at the end, which I doubt, we could get all three up if you wanted to get a broader opinion. So without further ado, our first speaker is Katy Burke, who's from SSE, and she's going to talk to us about the Keadby 3 project. So whenever you're ready.
I go forward. Great. Well, good morning, everyone, and thank you very much for inviting myself and the other speakers to come and address the forum this morning. Yep, as the slide says, and the programme, my name's Katy Burke. I'm the lead engineer for the Keadby 3 CCGT and CCS project. Next slide. Oh, oops. I think I've gone too far. Yeah, so for those who don't know of SSE Thermal, we are the operator of 5 of the most flexible and efficient gas-fired power stations within the UK and Ireland. They complement our renewable side of the business, which you may be perhaps a bit more familiar with, but that provides reliable and flexible power capability to support the market for any changes and events that we might see there. And the jewel in our crown is our 840 megawatt Keadby 2 project. So when completed, we're looking for, hopefully for commercial operation and handover to us within the next month. It will be the cleanest and most efficient CCGT in Europe. So we're very proud of the developments that we've got at the Keadby site. You may also not be aware that we own around 40% of the UK's conventional gas storage sites. They're located at our facilities at Albury and Attic in the East Yorkshire. So yeah, we support the gas industry there. Okay, so what is Keadby 3, the project? So it's a combined cycle gas turbine power station which will be equipped with post-combustion carbon capture capability. We're co-developing it with Equinor, who are a Norwegian energy company globally operating, vast experience in the power industry. And we're aiming to be the first UK project or the UK operational project for CCGT equipped with post-combustion CCS. So when operational, in a baited mode, the CCGT will generate between 700 and 800 megawatts. And we sit within the zero carbon section of the East Coast cluster, and they were announced as a Track 1 cluster by the Department of Business, Energy and Industrial Strategy last year. And that opened the door for us to apply as a power project in the cluster sequencing process. So we completed a 3-month pre-feed in the summer of 2021, so about a year ago. That was a competitive process between 2 consortia offering different technology solutions for post-combustion carbon capture. We went through a selection process and we awarded a 12-month full feed contract to ASD. So that's a consortium of Aker Solutions, Siemens Energy and Doosan Babcock. So that will run until May next year. The carbon capture technology will be provided by and developed and licensed by Aker Carbon Capture, which is a subsidiary of Aker themselves. So when operational, we expect the plant to capture approximately 1.5 million tonnes of CO2 annually, and that equates to approximately 5% of the UK government's 2030 target. So it's a significant contribution to what the government are trying to achieve. We submitted our development consent order application in June last year to the government, and we expect a determination from the Secretary of State at the end of this year, sort of around about December, all being well, and that will obviously allow us to then fully progress our development. So We were delighted to announce on the 12th of August, BEIS announced us as a Track 1 project in the cluster sequencing process as a power project, one of 3 in our cluster that were announced. So this means that we are given priority with the government to progress to detailed negotiations on the delivery of the project, really. So at the moment that involves what we're terming a due diligence phase. So representatives from BEIS want to kind of kick the tyres on our project, look at our submission, our business case, our technology solution, and really kind of get to grips with what we're trying to offer. So where is Keadby? I don't think I've got a pointer, unfortunately, but we're in North Lincolnshire. So this large town here, the resolution's not great, but that's Scunthorpe. So we're about 5 miles to the west of Scunthorpe at our existing Keadby site. So the river going up and down sort of north to south of Trent, and I'll show you next slide. So this gives a bit more indication of the scale of the site. So at the very north of the site, you'll see up there that's our existing facility, which is Keadby 1. The under construction Keadby 2, which is just beside it, and you'll see the construction village and the cooling towers coming to kind of down the screen. The 400 kV National Grid substation, which all our facilities in that area will connect to. And this little guy here, this wind turbine, that's part of the Keadby wind farm, which SSE Renewables own also. So we've got a lot of interest in the Keadby site, a lot of development. The Trent in the top of the picture running north to south, so the picture's coming towards the west, and the Stainforth and Keadby Canal, which will be our water source for the plant. And the mock-up here is an indication of what Keadby 3 could look like. We have the power island kind of in the middle of the site, and the carbon capture train coming from the power island. You'll see there's a couple of site constraints, so we've got some power lines kind of bisecting the site here. So we're siting our admin facilities and workshops and things over at this section. Also the wind turbine here causes a constraint. We have an exclusion zone. It's kind of almost a circular area here to protect the plant in case of a failure of the wind turbine. So this will be used for water treatment facilities and things, but the core plant's much further away. So that kind of gives you an indication of the scale. It's probably bigger than the 2 power stations up here combined, so it's an extraordinarily sized installation. So we're now 4 months into our FEED study, so I just want to talk about some of the key challenges and some of the focus areas that we have at the moment on the project. So I'll jump to the dispatchable power agreement first of all. So the dispatchable power agreement is the mechanism or the main subsidy mechanism by which the project can happen, and which it's funded, and that's from government. It totally underpins our business case, and we are looking at some of the deliverability aspects of it and how we can make sure our project delivers what government needs when they need it. So for example, our project needs to be in commercial operation by the end of 2027, which is only 5 years away. So that's a challenge. It's got real focus from us at the moment, and how we deliver on time, how we satisfy the operational requirements of government, the capture rates they require, the plant response times, and that needs to be demonstrated in testing, which we'll do a significant amount of during our commissioning process. We also have the interface with the TNS so that's the transport and storage network for the CO2. So it's actually being developed in parallel with our project, which brings a range of its own challenges. Obviously developing 2 completely separate assets which will interface and interact with each other, and having design processes happening at the same time is quite a challenging endeavour. So at the moment we're looking at how we tie into the network, what safety functions are required, how the control systems on each side are going to interact, and how we basically how we protect the local area, and how we integrate those safety functions together. The third one being CCGT and CCP integration. So really we're looking at what design features we need to ensure that the capture plant can respond to what we would consider as business as usual for a power plant, for a CCGT. So for example, looking at frequency response capability. So when the CCGT operates such that it follows the grid frequency, if there's a lot of intermittent wind on the system, the frequency, the power system tends to kind of fluctuate slightly, and the CCGTs will follow it to ensure that the frequency remains quite stable. So how do we look at the capture plant and make sure that it can also follow what the power plant needs it to do? So there's a big focus on the plant control system and also physical control devices for example, steam flows, chemicals, that kind of thing. And finally, dispatchability. Dispatchable flexibility is at the core of what government are looking for. They're looking for plant to be able to come on quickly, be able to respond to the demands of the system. So how do we look at the inherent processes in post-combustion carbon capture? So for example, heat requirement for solvent regeneration. How do we do that if the plant's offload because it's not required by the system? How are we able to maintain what the plant needs to do without supply from the main power plant? Plant availability, how we maximise the availability of the plant again comes into making sure that we're providing what the system wants, how we look at redundancy of plant, spares, so that's quite a big focus. Also, again, sort of capture rate and performance go hand in hand. So the performance of the solvent, the Environment Agency are looking for very specific requirements to determine that the solvent the performance can be monitored. The waste products are known and understood, and there's testing to demonstrate how the solvent performs under different operational conditions. So we have to make sure that we satisfy, that's another stakeholder that we need to bring along with us in this process. So I suppose in summary, I know this is obviously quite a short presentation, and it's unfortunate that we're not able to go into a lot of the technical detail, but unfortunately it's intellectual property that's very heavily commercially protected, so we can't go into a lot of that. But I hope you understand, or I'm able to demonstrate the scale and all the, I suppose, myriad of challenges that we face kind of bringing these products to market and bringing them to market at scale, and how we deploy them to meet the climate change targets that were set. So thank you, and if anyone's got any questions, I'd be happy to answer them.
Good. Thanks very much, Katy. We'll get some of the roving mics roving around. The first question comes online, and it's come from James Varley. And the question is, what were the reasons for selecting acre capture technology? And I assume the emphasis is on the technology as opposed to why you selected the company. So why did you go with that?
The technology, so I can't go into too much detail because it's a commercial selection process. However, I can say that the technology was able to satisfy design requirements that we had, performance requirements, I suppose business case requirements. The selection process is quite a detailed process going through, obviously looking at a host of things, safety and compliance with planning conditions, environmental conditions, and we'll have to look at a submission as a whole, and they were the selected partner based on a myriad of criteria. So unfortunately that's really all I can say on that.
Yeah, okay.
I say it's a little bit disappointing, but yeah, that's what it is.
Thanks. Okay, take the first one. Oh, have you got one back there? Fire away. Oh, John.
Yeah, John Gibbons, UKCCSRC. Have you decided yet how you're going to handle the flue gas addition? Are you going to run with an open stack or have some dampers in there? Or?
We've got dampers within the HRSG, so that will be sealed to ensure that there's no leakage within. So that's under detailed design at the moment.
Fast acting dampers.
Sorry?
Fast acting dampers.
Well, yeah, there's several functions that they have to perform. For example, we have to stop water getting in, rainwater, we have to have fast action, and we have to have a tight seal as well. So some of them are counterintuitive to each other. They are big pieces.
Yeah.
So fast acting doesn't really I suppose, so well with that. So,
And do you think
something
that'll be okay to avoid back pressure on the gas turbine?
at the moment, yes, there's certain components within the CCP that allow us to control and make sure the back pressure on the gas turbine is within tolerable limits. But yes, that's something that we're looking at with Siemens and they're aware of. But yeah, that's part of the design process.
Next question's down here.
Hi there, Meijner from Spec Harriet Watt. I was wondering, this presentation triggers loads of questions, so I won't ask them all now. It would be fantastic if some of this would come in, some of the pre-feed or feed material would come into public domain so that we can, use that in our research. Hint, hint. My question is the following: what are the design response times for the power plant and the capture plant, and are they exactly the same, or do you have kind of transition regimes between ramping up the power plant and the capture plant?
So at the moment, there's two influences on the power plant's response time. So we have to respond to the UK grid code. So we have to provide the appropriate response times as required by grid to ensure grid stability. There's also a provision within the dispatchable power agreement for plant response times as well. So the focus is on the power plant, and yes, the capture plant will have to follow. I'm not 100% sure what leeway there will be to allow for any sort of settlement period, for example, on startup, to provide the correct specification for going into the transport and storage system. I think that's still to be determined.
But may that also mean that, for instance, when you have a complete stop, right, and you have either a cold or a hot start, that you will, when the power plant starts up, the capture plant isn't completely running yet and doesn't capture all the CO2?
We're looking at options for example, say a two-shifting regime where the plant will be on for peaks in power demand and come off. We're looking at how we can, so we have a requirement within the dispatchable power agreement for a specific capture rate over a certain period. So we need to look at options, so we need to look at when the plant's operating in steady state and also when it's not, and how do we provide, obviously because capture rate during startup will be not as good as in steady state. So how do we, I suppose, get to the steady state value as quickly as we can? And those are options that we're looking for in the design as to how we have lower capture rates for a short time as possible to get right up to that steady state value, and that is again is part of the focus of our design.
I've got time for one more question, so down here. Thank you.
Nice. Adrian Topham, Crown Estate. Thanks, Katy. It's one question in two parts, so feel free to answer it whichever. So one is around the relationship between SSE Thermal and SSE Renewables, going back to Hannah's question earlier yesterday. And the second one is around the fuel type you're using. You're using natural gas or you're using hydrogen? I might have missed it, you might have explained that. I know it's a possibility. Sorry,
yes, so it's natural gas from the nationwide transport network. So the same gas as you have in your house will go to the power station.
Is there not talk of a hydrogen source at some point as well?
We're looking at options at the Keadby site in partnership with Equinor. We're looking at developing hydrogen capabilities, but at the moment Keadby 3 will be a gas-fired combined cycle gas turbine station. With regards to SSE and SSE Renewables, we're both part of the same parent company, SSE, but we are, I would say, split insofar as we're our own directorates under our own director, and our staff will focus and will be part of the thermal business. And the renewables will deal with it, but we're part of the same parent company and we share the same offices, and we're together in so much as we just kind of have a split, and we report to, I suppose, a different directorate really. That's it.
Okay, thanks very much. Let's just show our thanks. Thank you very much. That was a really interesting presentation, good insight. So our next speaker is Chris Gilbert from Phillips 66 Humber Refinery. And Chris, when you're ready, the floor is yours.
Morning, I'm Chris Gilbert. I'm the manager of all our decarbonisation projects we're doing at the refinery. So carbon capture plus a lot of other activity which we'll talk about as we go through the slide. So Phillips, most people never heard of Phillips 66. So we're a US company. We've had a refinery in the UK for over 50 years now. Refinery produces around 20% of the UK's road fuels. 6 refineries left in the UK. You know us more from our jet marketing brand at petrol stations. So we're a traditional industry. We're looking at how we move in the energy transition because the products we make today will still be in demand by society, we believe. We're still going to be relevant in the future, but how do we do that in a lower carbon intensive way? And we're already making strides on that. So we've started running used cooking oil and other biogenic feeds, and that's allowed us to make sustainable aviation fuel. So we've got a multi-year contract now with British Airways. Another product we make on the refinery that's very relevant for the energy transition is we're the only manufacturer in Europe of synthetic graphite coke. So that comes out of the bottom of the barrel, and that's used in lithium-ion batteries. So there's a big growing market in electric vehicles. We make enough coke, synthetic coke, to power 1.3 million electric vehicles. So we've been looking at what we need to do to become the refinery of the future. That's a concept we've been talking about. So you've got your scope 1, 2 and 3 emissions. So things like renewable fuels all come in scope 3. So we've been looking at used cooking oil, biogenic waste like I talked about, batteries in our products, sustainable aviation fuels, etc. But the bit in the middle are our processing emissions. So we produce 2 million tons a year of CO2 in our manufacturing units. So we're looking at ways how to capture that carbon. So a couple of years ago, we did a study with Wood about what technologies do you apply to capture those 2 million tons. So left to right, the first one, energy efficiency. That is by far the easiest way of reducing your emissions, just like at home. Actually makes you money, but that only gets you a small percentage. Then we looked at alternate technology. So carbon capture is actually a cost-effective way of capturing emissions. So we divided the refinery up into 3 areas, and so we're going to install 3 carbon capture plants over time. And then as the refinery's expanded, we have several geographically remote large industrial furnaces. So it's more cost-effective to refuel those with hydrogen than use carbon capture. So the work we've done, we got to 90%. We think we can get higher when we start looking at the technologies available. So talk more about carbon capture. So we sit adjacent to a cogen gas-fired power station run by VPI, a lot of interdependencies. One thing we're learning in this whole transition is around collaboration. So it made sense to partner with the power station next door run by VPI that's where Humber Zero came from. So we've been working together regionally as well. on how to progress carbon capture. You can see Humberside, where we're located, is the largest industrial cluster in terms of emissions. Okay, with all the development work going on, we're at the intersection in Immingham of two potential pipelines. So you've got track 1, Katy spoke about, that's the one north, East Coast cluster. And then there's another pipeline, track 2, going down to Thedlethorpe, run by Harbour Energy. So a bit more specifics about our first carbon capture plant. So FCC is a fluidized catalytic cracker, so it takes bottom of the barrel from the crude towers and upgrades it with pressure and temperature and catalyst to higher value products such as LPG, gasoline, distillate, etc. And the post-combustion, okay, the catalyst is regenerated and then produces CO2. We're going to capture that CO2 using a capture plant. So this unit runs continuously, 5 years between turnarounds, so it's different than what you heard before on a gas turbine. So this will be the first time this has been done on a refinery. So first of a kind capture plant, retrofitting it. We've been successful. We've started FEED. We've been successful in various phases of government funding through BEIS. Need to acknowledge the government is really driving this and partnering with industry. So we've selected our carbon capture licensor, which is Shell, working with Worley, our engineering contractor, on FEED now. But as a company our size, we also leverage, we spend a lot of capital around the world, so we can leverage our major projects group. And we also have a research group in Bartlesville, Oklahoma, which is helping us a lot with the technology selection. So FEED's ongoing, and then we recently, just like Keadby, we've been successful as an emitter project for track 1, cluster sequencing. So very simple pictorial diagram of what carbon capture looks like. You have your emission source, tie into the stack. Now for us on an FCC, there are a lot of contaminants. You have SOx, NOx and particulates. One thing we've learnt on our development work is pre-treatment is absolutely key for solvent stability and void degradation. So spend a lot of time on the pre-treatment. So that's going to be a wet gas scrubber with wet ESP, electrostatic precipitator. Also allows you to recover energy. These are real energy hogs, the carbon capture plants. Go through an absorber, extract the CO2. CO2 goes to, the lean gas goes out. The rich amine, a bit of heat integration, and then regenerated, and then compressed and out to the pipeline. What's not shown on here is the reclaimer for the amine, so the solvent conditioning that is an integral part of the process. So we talked about publishing technology information. So we went through quite an extensive technology selection. So we surveyed the market, went through, worked with our company experts, surveyed existing plants, did a competitive tender, worked through, normalized a lot of the data and came up with a selection. So we've actually issued a technology selection report. You can access that from the Humber Zero website. Project timeline. So we started 2021. We're in FEED at the moment. We're looking for start making investment decisions next year. So we got a first investment decision in 23, goes up through corporate approval, and then our final investment decision will be in 2024 when we start construction, and we're going to be online at the end of 2027. So it's a long gestation period for a project. It's pretty typical. Again, predicated on having the pipeline available. So, a couple of summary points. We're going to create jobs. We're going to secure and sustain jobs. We're an energy-intensive industry. By having carbon capture and still having industry in the region allows us to continue with the economy, but also grow the economy. This is a great opportunity in terms of everything that's going on with levelling up, etc. Keeps UK industry attractive. Yeah. So if we don't do this, then what could happen? Energy-intensive industries like this could move. You could easily refine oil anywhere around the world, and then the CO2 would be emitted there. Yeah. Does that make us competitive here? So this is something we should be doing as a UK. Another point we're very keen on is we've got to take the public with us. This is a societal change. This is a dramatic change that's going to happen. The amount of investment, the amount of carbon capture and other technologies to decarbonise is going to be huge. So we're spending time with the local community, talking about them. That's happened on other projects. One in Holland didn't get permitted because of the feedback from the local community. We're working with the Environment Agency, HSE, on developing legislation. There is no legislation yet on some of this work, so we're working with the relevant authorities on this. But it's also a great opportunity. We're a traditional industry, but we need people. We need people. We need engineers. We need chemists. We need IT people. We need all the construction workers. There's going to be a huge lift there. So we're spending time in our outreach with schools to encourage people to come into the industry. So exciting times. I say to people, it's my 39th year in the industry. This is going to be a step change in what we do. It's exciting. So thank you. That's everything from me.
Good. So let's take some questions from the audience, and I'll wait for some to come in online if there's any. Go ahead. Microphones.
Thank you. Hi, Imran Ahmed, Newcastle University. I'm a PhD student. One of the things you mentioned is that it's a very energy-intensive industry, and capturing the CO2 is a very energy-intensive process, and you can refine oil anywhere around the world. So when you put on this CCS unit, how do you remain competitive with refineries in countries that are maybe not legislating and making people do this?
It's a very good point. So I think there's a lot of discussion in Europe about having a carbon wall. So called CBAM. I can't remember what the acronym stands for. So you will need to enact legislation to make it to have incentives for us to invest in this, versus carbon price, versus offshoring what we do here today,
Thank you.
Okay. Can I ask a question, if I may? So in your presentation, you showed the timeline for the development and the technology selection, etc. But you also showed a picture of an amine scrubbing facility. So is the technology chosen, or do you feel that that's the most likely route?
No, it's technology chosen. We're using amine. So we selected our licensor. We're working through that. We shall, and we're working through FEED now. And we'll finish that next year.
So I guess it's the provider that is under consideration.
The
technology provided, the specific?
no, it's already been selected.
Oh,
yeah.
that's selected
Yeah.
as well.
Yeah.
Okay.
Yeah.
Good. Okay. More questions, John?
Yeah, quick question, Chris. Do you think you've got aerosols in your flue gas or fine particulates?
That is very much on topic at the moment.
Yeah.
So as we go to consenting phase, so we're looking to put our permit in with the EA at the end of this year. So there's an awful lot of modelling being done with our consultant. I think we've got people here from AECOM here today, so they're working on the modelling, of emissions.
But I mean, have you just had a look at the flue gas and got any idea of the particle count or whatever?
Yeah, so in terms of what's leaving the FCC, we've got a very good idea, so we need that now for our environmental permit. Yeah. So the trick then is, what can the pre-treatment do to minimise the amount of particulates and SOx and NOx will then cause the amine degradation and come out in the flue gas. Yeah. So
yeah, I was thinking more of amine carryover as aerosols.
Yes.
Was
Yeah.
they're always the nasty one that is hard to predict.
So that's all part of the design. So very much a hot topic at the moment. Yeah.
Mm.
Okay. Do we have any more? No? Okay. Chris, thank you very much for the presentation. Our last speaker is Chris Williams from Industry Wales. Chris and I are on the same flight later, so I don't need to rush him or keep him to time, because he's got the same problem as me. So Chris, when you're ready, over to you.
Thank you. So I'm Chris Williams. I work for Tata Steel, but I'm seconded to Industry Wales, which is an arm's length Welsh government body. I was seconded because Tata Steel, I suppose, initiated the South Wales Industrial Cluster and then sort of recognised it shouldn't be actually leading a regional decarbonisation programme. So we worked with Welsh Government, and the conclusion was that I should be seconded from Tata into Industry Wales and to continue to lead and develop and build the industrial cluster around that. So South Wales, down the bottom on the left-hand side there, I suppose from a CCS perspective, what's known as a dispersed area. So no local geological storage of CO2, no known local geological storage of CO2, I should say. And so we're exploring, or having to explore, CO2 shipping and all that comes with that. So in terms of the cluster sequencing programme, obviously what's key there is to get the stores up and running so that we've got somewhere to ship our CO2 to. So completely supportive, and wish all the Track 1 clusters huge success in successfully proving CCS in operation. So important for us down in the south as well. I suppose in terms of Track 2 then, we would hope that we would fit into Track 2 as a shipping, so as a carbon capture site that's looking to TNS, transport up then to a store up the north. So that's kind of where we fit. So obviously not Track 1, we'll hopefully fit into Track 2 as a CO2 shipping opportunity. In South Wales, it is a big industrial cluster. It reaches all the way along the bottom of the coast. It's that big partly because we were trying to understand strategically where our infrastructure was, where our demands and where our generations were. And it ended up being from coast to coast along that bottom. It is the industrial heartland, I suppose, of our area. It's the second largest CO2 emitting area in the UK, mainly because we've got steelworks and an oil refinery. And then the rest then is made up of general manufacturing, so Royal Mint, your coins are made there. Jammy Dodger biscuits are made in South Wales. Pot noodles with Unilever are made in South Wales. There's a list of general manufacturing sites that are all looking to try to understand how they're going to decarbonise, how they're going to be able to brand themselves as net zero going forward in the future. So we sort of came together in January 2019, and it's at this point I always thank the other, particularly Teesside, Humberside, Hynet and Scotland. I spent quite a bit of time with the other clusters as they were shaping, developing. They've been round for quite some time, and they were all eager to share and help us get up to speed. So thanks to the other clusters for that. So we knew we were the spread of industries that you could see along that bottom of South Wales. We knew that we've got LNG import capability into Milford Haven, so about 20 to 30% of UK natural gas normally comes in through Milford Haven as LNG. We've got a huge tidal range, huge floating offshore wind capability, but no local geological storage of CO2. So how as a group do we work out our net zero journeys individually, but as a region, with those opportunities and that challenge? So that's really where we were in 2019 and started to move our way further forward. So for our individual sites, whether you're a biscuit factory or a steelworks, we basically, as has been mentioned this morning in other presentations, you start to understand how you can get to net zero. We broke those down really into 5 steps through resource energy efficiency, fuel switching, so that could be electrification. So quite a lot of our industries are looking straight for electrification. We've got hydrogen. Then, of course, where will that hydrogen come from? And where will it come to that industry quickly enough to enable it to transition over? Or maybe biofuels. So we've got biomass, biofuels options as well. Then smart networks in terms of how do we use waste heat, waste products, industrial symbiosis, sharing. How do we build that into our areas to try and make our operations as effective as possible? So if we're looking at carbon capture kit, etc., how do we try to bring inward investment around that process as well? Carbon capture utilisation, as was shown yesterday, the Tata Chemicals site is an example of that, where they're capturing the CO2 and using that instead of buying in CO2. So what opportunities have we got as a region within that area and to develop that further? And then last but not least, the all-important, of course, for today in terms of carbon capture storage. If we've got our industry as lean and green as possible through those first 3 steps, we've still got huge amounts of CO2. How are we going to ship that away? What does that develop? Are we going to be looking at local pipelines from small area to small area, or undersea loops of pipes? How do we connect that area together on that huge span of South Wales? And of course, that's where universities are key to supporting us with those 5 steps individually. So suppose IDRIC was as a package for all 5, UKCCSRC for number 5, and also overlaps into other areas as well. So university, our programmes of research are fitting into those sort of 5 steps typically. Of course, shipping CO2, isn't, as I showed in my second slide, isn't just about us. If you look at the Cavendish project on the Thames, London, you'll see that developing as a CO2 export via ship capability. Same then with the Solent and ExxonMobil in terms of shipping from there. That's developing momentum now with SGN. And of course, in terms of Europe, we're probably all aware of the Northern Lights project and the CO2 shipping capability that's coming in through there. The Ghent project, which I noticed the other week. And also, of course, there's the ZEP standards and development of programs and backing up, helping support the development of CO2 shipping as a capability. Because as Chris said earlier, as we're sat round the table, we're mainly multinational industries headquartered abroad. So I'm a local person, I live in South Wales, I work in South Wales for a multinational. What can I do to make it as attractive for my multinational to keep wanting to invest in my area, to keep jobs in my area? There's about 100,000 people working in South Wales Industrial Cluster directly, plus many times that indirectly. It's 8 billion GVA to the local economy. That's huge. That's all at risk if we can't develop the CO2 shipping capability, and that huge hydrogen demand we'll need relatively early to enable our industries to transition over through a just transition. So we started to try and understand what's our regional strategy likely to be going forward. We knew Industrial Decarbonisation Challenge Fund money was coming. How do we pull those opportunities and that challenge into a scheme, into a plan that starts to help us and guide and develop the capability that the region will need? So on the top left-hand side, as I've said, 20 to 30% of UK natural gas coming in through Milford Haven. we said, well, hang on, actually we can theoretically then support net zero for 20 to 30% of the UK. So it's not just about Swick, it's actually wider, coming around into the whole southwest of the UK, in principle, in theory, by converting that natural gas into hydrogen. What does that do? That also then initiates CO2 shipping from the area, which are other hard to decarbonise industries, steel, cement, chemicals, will then be able to utilise that CO2 shipping capability. So we start with a hydrogen project that initiates hydrogen, it initiates CO2 shipping, which then acts as almost like a key to unlock a chain reaction from the left-hand side of the diagram, further then to the right-hand side of the diagram, as our multinationals then can start to see hydrogen in the area, CO2 shipping, leaving the area, they know they can invest and develop and plan our way through. So our industries almost will be probably scheduled from left to right as that capability grows. So we started to shape that. We also knew then, of course, with the 20, 30, 40 gigawatts of floating offshore wind, the green hydrogen capability that will bring, how do we tie that into this regional map and regional strategy and regional way forward? So the Industrial Decarbonisation Challenge, we then had a selection of those processes that fit into that jigsaw, support funded, that will help us and take some of those through to feed by 2024, and hopefully that will line up then nicely for our Track 2 type bid for CO2 ships, blue hydrogen, tying in with the power station. What that also initiated, because we started momentum, we got people around the table, we got people collaborating. Milford Haven then with the oil refinery, the 2.2 gigawatt Pembroke power station, the 2 LNG import terminals, the renewable capability that's coming there, started to form a tighter, what was called originally a mini cluster, but they didn't want to be called a mini cluster, so they're now a super place. So we have an overall cluster now, we've broken down into 4 super places. And they are coming through in their own strengths with almost like Swick as a foundation for these other areas to grow and develop out of. So the Milford Haven Waterway Future Energy Cluster had its launch in the House of Commons in June, and that's kicking off then a whole programme related specifically around Milford, around CCGT, around green hydrogen, blue hydrogen and CO2 shipping. So that's, you know, an exciting area that's developing our overall area first. In Port Talbot then, so we go further east to the right. Port Talbot, the steelworks, and the biggest industrial CO2 emitter in the UK, has a huge challenge. It's billions and billions of pounds for it to make its next step. Of course, by us developing that CO2 capability, we're making it easier for Tata to understand what its end position might be by 2050, but also the steps it can go through in a phase just transition through to those points. So we've got CO2 shipping, we can pull ships in. We've got some CCU capability for SAF as well, and other supply chain chemicals with Lanzatech building a plant next to the works. Then I haven't got slides for these areas, but just going further east as well, Barry with Dow, Hexie and Cabot. There's a cluster developing around there, around hydrogen, around circular economy. And then further east in Cardiff and Newport, we've got super places developing now in those areas as well. All looking to west, mainly to Milford Haven, but also as we look even further east, and we start to tie in with Avonmouth, we start to understand, it's starting to ask, what am I going to be doing? How do I tie into this process? How are my industries going to be net zero? How do I make sure I don't lose my industries? And it's spreading further east. So we're just trying to understand, through that shipping capability that will be developed, how do we pull and shape all that into one plan for Swick, but also overlap then into England and further away. Thank you.
Okay. Questions from the audience, please. Okay, I'll get us started with one. So Who's going to ship the CO2, and what sort of framework do you see that operating under?
Yet to be determined. We're working on that. So the IDC funding is supporting design, the feasibility studies, modelling. So there's quite a lot of feasibility, pre-feed for some, and modelling going on in terms of understanding jetty location, shipping capabilities, the port, with LNG ships coming in, oil refinery being fed and products coming out, CO2 ships added onto that. How does that all fit and align? And where the destination is as well. So where's it going to go to? Yeah, that's obviously going to be a big part of that track too. So I suppose we'll wait to see what our partners, our collaborators come through and look to pull forward.
Okay, good. Yeah, Maxine?
Do you want me to show?
No, they're making their way.
Maxine Ackers, British Geological Survey. Chris, that was my question. Where are you shipping to, and would you have the preference to use UK CO2 storage capacity, of which we have plenty, rather than go to a competing nation?
I would hope that a UK store offers the least cost shipping and the lowest gate fee.
Thank you. I think for me that's the right answer.
Yeah.
Okay, we've got one question here.
Thanks, Chris. Adrian Topham, Crown Estate. Would you like to elaborate a little bit more about the emission gases from the different industries and the things you were telling us yesterday about combining between the different sectors, and what comes out of steel, what goes into refineries, and all that sort of synergies chemically?
Yes, but this is, we had a discussion over a whiskey. We'd spent quite a bit of time with Cambridge University on the Use Less department with Allwood and Cullen book, materials with both eyes open, and that sort of inspired us to understand as a region what we can do for industrial symbiosis. So mapping, Sankey diagramming, chemicals and flue gases, heat, and then digging down in detail in specific areas and looking for opportunities where we can pull different industries together, maybe move, maybe interconnect via pipe, particularly around, so some of our sites are right near a dock, right near a port. Some of our sites are, as we were calling them, further up the valleys. How on earth are we going to get CO2 from them, or how are we going to get hydrogen to them? And what opportunities have we got? Do we need to move that industry further down? How does that all configure? But I suppose the example we had yesterday was, if you look at the steelworks in Teesside closed, unfortunately. The steelworks in Port Talbot stayed. The chemical works in Port Talbot closed, and the chemical industry stayed in Teesside. You know, ideally, you'd have a steelworks next to a chemical plant, because the steelworks creates what it calls works arising gases of carbon monoxide and hydrogen. And of course the chemical industry buy what they call syngas. So if the two had been speaking all these decades, then industrial symbiosis would have had deep embedded decarbonisation benefits as well.
Okay, last question from Hannah.
Hi, Hannah Chalmers, University of Edinburgh. You're relying on quite a lot of CO2 ships, I guess. I don't know if you want to share some thoughts on where the sector is in terms of making enough ships and them being available for use in the UK and around the UK.
I suppose to my knowledge, we're following from what Shell are doing in Northern Lights, and I suppose we'll be looking to learn and develop off those. I know what's been explored in Milford Haven is the type and size of ship that we'll need, and that'll be based on a little bit like Katy went through in terms of the CCGT understanding how it's going to run. That will define how much hydrogen and how much CO2 we're going to need to ship. And also we're going to inject hydrogen into the grid and maybe to other local industry as well. So through understanding that, we'll understand what size of ship we need. We'll understand what size of ship will fit in the port and go from there. So I don't think you answered your question.
An interesting sort of observation. I'm sure we can take the rest over coffee. Thank you.